A new study reveals comet airburst evidence from 12,800 years ago. And this is by Sonia Fernandez, University of California, Santa Barbara. Now we know what happened at that time. That was the CLovis Comet, the younger Dryas, a mini ice age. And what they say is that it was an airburst. It wasn't really an impact, but that even caused such tremendous upheaval. You're going to see a map showing the CLovis Comet debris that has already been found. It even, basically they found it from a layer of ash that was found initially in North America. They believed that this comet caused a tremendous fire event in the Northern Hemisphere. They first found it in North America, then they found it in Northern Europe, and they found bits of debris from this same comet all over the world. And the latest has been around South Africa. But this is just one of the comet impacts in Quebec, okay? And damage to our Earth, obviously. But the new study says that it was an airburst. Researchers continue to expand on the case for the younger Dryas impact hypothesis by the CLovis Comet. The idea proposes that a fragmented comet smashed into the Earth's atmosphere 12,800 years ago, causing a widespread climactic shift that, among other things, led to the abrupt reversal of the Earth's warming trend and into an anomalous near-glacial period called the Younger Dryas. In other words, it was an ice event, turning the climactic shift into a mini ice age. And now UC Santa Barbara Emeritus Professor James Kennett and colleagues report the presence of proxies associated with the cosmic airburst distributed over several separate sites in the eastern United States, New Jersey, Maryland, and South Carolina. Materials indicative of the force and temperature involved in such events, including platinum microspherules, melt glass, and shock fractured quartz. The study appears in the journal Airburst and Cratering. Now, what we found, he said, is that the pressures and temperatures were not characteristic of major crater-forming impacts, but were consistent with so-called touchdown airbursts that don't form much in the way of craters, Kenneth said. This is basically what happened in Siberia with the airburst asteroid impact. Now, the Earth is bombarded every day by tons of celestial debris in the form of tiny dust particles. On the other end of the scale are the extremely rare and cataclysmic impacts like the Chicxulub event that happened 66 million years ago, caused the extinction of the dinosaurs and other species. Its 150 kilometer wide, that's 93 miles, impact crater can be found in the Yucatan Peninsula in Mexico. Somewhere in between there are the impacts that don't leave craters on the Earth's surface, but are nevertheless destructive. The shock wave from the 1908 Tunguska event knocked down 2,150 square kilometers, that's 830 square miles, of forest, as the roughly 130-foot diameter asteroid collided with the atmosphere almost 6 miles above the Siberian taiga. The comet thought to be responsible for the Younger Dryas cooling episode is estimated to have been 62 miles wide, so that's about 10 miles bigger, 10 times bigger than the Tunguska event, much larger than the Tunguska object, and fragmented into thousands of pieces. The sediment layer associated with the airburst stretches across much of the northern hemisphere, but can also be found in locations of south of the equator. This layer contains unusual high levels of rare materials associated with cosmic impacts, such as iridium and platinum, and materials formed under high pressure and temperatures, such as magnetic microspherules, cooled down metallic droplets, melt glass, and nanodiamonds. Shocked quartz and amorphous silica. The researchers are particularly interested in the presence of shocked quartz, indicated by a pattern of lines called lamella that shows stress great enough to deform the crystal structure of quartz, a very hard material. This creme de la creme of cosmic impact evidence is present in impact craters. However, linking shocked quartz to cosmic airbursts has proven to be more of a challenge. In the extreme form, such as when an asteroid hammers into the Earth's surface, all the fractures are very parallel, Kenneth explained. In the realm of cosmic airbursts, different variables are present in the realm of cosmic airbursts. When you think about it, the pressures and temperatures that produce these fractures will vary depending on the density, entry angle, altitude of the impact, and the impactor size. What we found, and this is what is characteristic of the impact layer called the Younger Dryas boundary, is that although we do occasionally see in the quartz grains examples of the traditional shocked quartz with parallel fractures, we mostly see grains that are not parallel, he said. These fractures are seen in an irregular web-like pattern of intersecting, meandering lines and surface and subsurface fissures, in contrast to the parallel and planar deformations of impact-associated shock quartz found at craters. These subparallel and subplanar deformations are due in large part to the relatively lower pressure caused by explosions that occur above the ground, the researchers assert, as opposed to impacts that make contact with the Earth. What these sediments do share with the shocked quartz at crater sites is the presence of amorphous silica, melted glass in these fractures, and this is what we're seeing here, an impact. This is an impact, obviously. This is not an airburst. Now, and that, the researchers say, is evidence of the combination of pressure and high temperatures greater than 2,000 degrees Celsius. That could have come from a low altitude bolide airburst. And similarly, fractured quartz grains and melt glass have been found in more present day samples of above ground explosions, such as at the Trinity atomic bomb test site in New Mexico. At roughly 20 kiloton bomb, this bomb was detonated atop a 30.5 meters, 100-foot tower. These low-pressure shocked quartz grains join a growing suite of impact proxies that together make a case for a fragmented comet that not only caused widespread burning, but also abrupt climate change that resulted in the extinction of 35 genera of megafauna in North America, like the saber-toothed tiger and the mammoth and everything, and even the CLovis culture. Such as the mammoths and giant ground sloths, and led to the collapse of the flourishing human culture called CLovis, according to the researchers. Of course, everything was burned. They had nothing to eat, let alone all the other damage. Now, there's a whole range of different shocked quartz, so we have to make a well-documented case that they are indeed significant for interpreting cosmic impact, even though they're not reflecting a traditional major crater-forming event, Kenneth said. These are from very low altitude touchdown airbursts, almost certainly associated with cometary impact. And this is from Christopher Moore and colleagues of University of California, Santa Barbara. Please leave on phys.org. Please leave your comments, and thank you for your support. Support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support, and that you find all my content so interesting. You'll find the Patreon account details in the description box below.